Hey, good evening students. Today we are going to see in ladder frictions. Today's class we are going to see the basic concepts of ladder friction. So we know a ladder is a device used for climbing on roof or wall. So now we are going to consider a ladder which is placed in floor and rest on a wall. So consider a ladder AB and the length as L, and then it will have a weight that is W. Ladder is resting on ground at point A and leaning against the rough wall at B. So once again I will repeat it. That is, consider a ladder AB of length L and weight W resting on the ground at point A and leaning against the rough wall at point B. So rough wall, that is very important. Okay. If it is a smooth wall, so obviously friction won't be there. Because it's a rough wall, definitely there will be a frictional resistance. So now let us take the angle of the ladder with respect to the horizontal plane as theta. So if we consider that when the weight of man on the ladder makes instability to the ladder, that is, the ladder is about to slide or about to slips down, then the motion of the ladder will be towards down. So when the motion of the ladder is towards down, then at point B, because the ladder is slipping towards down, the frictional force will act up. So this one we are denoting as frictional force at point B. Then obviously we know that the wall is a support. So at point B we will have a normal reaction, that is NB. So once we know frictional force FB and then NB, obviously we can calculate the coefficient of friction at point B, that is mu B is equal to FB by NB. So now we will come to the floor. So the ladder is in contact with the floor at point A. So when the ladder slips down, so because of the weight of a man, so now when it is sliding down, obviously at point A, the ladder will slides to move towards left. So this will be the motion of the ladder. So once the motion of the ladder is towards left, obviously the frictional force will be developed towards right. So this one we are denoting as FA. So now we got frictional force. So obviously the ladder and the floor will have another reaction, that is nothing but a normal reaction, that is NA. So once you know frictional force at A and normal reaction at A, then obviously we can calculate the values of coefficient of friction at A, that is mu A is equal to FA by NA. So now you can see in this ladder diagram, so we have four unknowns, that is frictional force at A and normal reaction at A, then frictional force at B and normal reaction at B. So these four parameters are important in the ladder friction. So now, so as per our assumption, so this ladder is about to slide, that is impending motion. So for impending motion, we have to write the equilibrium equations. So in the previous cases, the equilibrium conditions are, we know that very well, summation of force along horizontal or x-axis is equal to 0 because the ladder is in equilibrium, because it's about to slide, it is not moving. The next condition is, we know that summation of vertical force is equal to 0, otherwise summation of force along y direction is equal to 0. Then the third one is, because it is an impending motion, the frictional force is equal to coefficient of friction multiplied with normal reaction. So we used to call these forces limiting friction. And one more important thing is, because we are having four unknown, that is FA, frictional force at A and normal reaction at A, and frictional force at B and normal reaction at B. Because we are having four unknowns, so we are having one more equilibrium equation, that is moment about any one point is equal to 0. So these are the four equilibrium equations we are going to use and solve problem in the ladder friction. So please draw the free body diagram again and then try to find out the relationship between the floor and the ladder and then wall and the ladder and how the motion occurs in the ladder and what are the parameters we have to calculate. Please go through once. Okay, hope you understood. All the best. Have a nice day. Thank you.